Hi, so this video is all about determining electron configurations based on the periodic table. Now, in one principal energy level, there is one total s orbital, which can contain a max of 2 electrons, 3 p orbitals, which can contain a max of 6 electrons, 5 d orbitals, which can contain a max of 10 electrons, and 7 f orbitals, which can contain a max of 14 electrons. Now, these are the block locations in the periodic table. So on the far left is the S block, which is the alkali metals and the alkaline earth metals. The D block is the transition metals, and the P block is pretty much anything to the right of the transition metals. And the F block is the portion of the periodic table that is detached. So this slide outlines what energy level to use depending on the period you're in. Now for the S and P block, whatever period you're in, you're going to use that same number as the energy level for those electrons. So like if you're in period 3, the S and P block, you will use the principal energy level 3 for those electrons. However, when you're in the D block, you're going to do the period minus 1. So if you're in the 5th period and you're talking about the D electrons, you'll really be referencing the electrons from the 4th energy level. So you're going to do the period minus 1. Now the F block, which is the portion detached from the periodic table, you're going to do the period minus 2. So if you're in the top portion of the F block, which is essentially coming from the 4th row or the 6th row of the periodic table, you're going to do 6 minus 2, which will tell you the electrons you're referencing in that instance would be from the 4th principal energy level. Now here is a diagram that, talks about the same thing I just referenced. So like if you look in the 6th period of the periodic table, the s orbitals are 6s. However, the f orbitals are 4f because you do that period minus 2. The d orbitals are 5d because you do the period minus 1 for d orbitals. And then the p orbitals are 6p because they stay the same as the row. Now this slide talks briefly about how to write the abbreviated electron configuration. So you find the closest noble gas with a smaller atomic number than the element you're writing the configuration for. And you write the noble gas, which accounts for all the inner electrons that don't react at all. And then you write the additional electrons for the element right next to the noble gas, which those additional electrons are typically the ones that are involved in the chemical reactions. Okay, so a few things to think about when writing these configurations is 1, you move from left to right across the periodic table. 2, it's easier to think about the helium element being right next to hydrogen and above beryllium. That'll make it easier when you think about writing those configurations. And 3, think about every time you move past an element in the periodic table, think of adding 1 electron to the orbital configuration. So for this first example for carbon, you move past hydrogen and helium, so you're contributing 2 electrons. So in the 1s orbital, there'll be 2 electrons. And because, like I said before, the s orbitals can only contain a max of 2 electrons, you have to move on to the next orbital. So you went past hydrogen and helium. There's no p block for the first sublevel, first principal energy level. So you move on to period 2, and you go to lithium and beryllium, which you're moving past both of those. So for the 2s orbital, that will be filled. And then you move over to the p block and go to boron and carbon. And you're trying to find the electron configuration for carbon. So that will be 2, since the period is 2. P, because you're in the p block. 2, because you're stopping at carbon. So you're going from boron to carbon. So for that one, the electron configuration is 1s2, 2s2, 2p2. Now for chlorine, you're moving past hydrogen and helium, so that's 1s2. Lithium and beryllium, that's 2s2. You're moving past all the p block, so that's 2p6, because you're moving past all 6 of those elements. You're going past the 3rd period s orbital sublevel, just s orbitals. So that'll be 3p or 3s2. And then chlorine is in the 3p block, so it'll be 3p5. Now nickel, this one gets a little more difficult because you're going into the d orbitals. So you're going 1s2, 2s2, 2p6, 3s2, 3p6, and then now you're down here in the fourth period in the S sublevel, so it'll be 4s2, and then you're moving into the D sublevel. So since, like I said before, you take the period minus 1, so it'll be 4 minus 1, which would be 3D, and then to get to nickel, you go past 1, 2, 3, 4, 5, 6, 7, 8 elements. So that last number will be 4D8. Now for the last example, gold, this one's pretty far down the periodic table. So it'll be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, and 4d10, and then 5p6, 6s2, and then now a good thing to remember here is you see where my cursor is right now on lanthanum? That's where the F block is essentially. Since it's detached, I know it's at the bottom, but really it's on this part of the periodic table. It's really just inserted on this half of the periodic table. So it goes lanthanum down to, I don't know the element name, but down to CEPRND. And a good way to remember that is just by looking at the atomic number. So you have to go from 57 down to 58 and through the F block before you can come back up to 72. So like I said, you have 6s2, and then you have to go down into the F block, and that you go all the way through. So that'll be 6 minus 2, which would be 4f14. And lanthanum is a part of the D block, so you'll go 5D, 1, 2, 3, 4, 5, 6, 7, 8, 9. So then 5D9. So that would be the electron configuration for gold. Now writing the abbreviated electron configuration is a lot quicker. So for the first one is carbon. So you find carbon and you look at the noble gas that's before that. So that'd be helium. And then you just account for the electrons after that to get to carbon. So it would be helium, 2s2, 2p2. Now for the second one, chlorine, the noble gas before that is neon. And then you'll add 3s2, 3p5. Now for the third one is nickel. So where's nickel? Okay, nickel's number 20, atomic number 28. The noble gas before that is argon. So you'll write argon, 4s2, 3d8. And for the last one, gold, the noble gas before that is xenon. So you'll write xenon, 6s2, 4f14, and then 5d9. 5d9. And then here are some individual practice problems. So if you want to pause the video for a minute to try some of those, and then I will give the answer. All right, so here are the answers for phosphorus and potassium. Now for silver, you go through 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, and then 5d9, or 4d9. Sorry, it's 4d9. Now for the element Db, which has an atomic number of 105, you're going to go 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, 5p6, and then here's where the F block starts to come into play. 6s2, and then you're going to go down into the F block, and you'll have 4f14, and then 5d10, 6p6, 7s2, and then again you have to go down in the F block again, and you'll have 5f14, 14, and then 6D3. Now writing these abbreviated electron configurations for phosphorus, that's the answer, and for potassium, that's the answer. Now for silver, where's silver? Oh, okay, so the closest noble gas that's less than silver is krypton, and then you have to account for those additional electrons, and that's 5s2, and then 4d9, and then for dubnium, the closest noble gas is radon, and then you have to include 7s2, and then 5f14, and then 6d3. All right, that's all.